From ancient civilizations gazing at its reddish hue, Mars has always been a source of fascination and wonder. The ancient Egyptians called it Horus of the horizon, while the Babylonians referred to it as Nergal, the god of war. Its distinct color and erratic movement across the sky made it a subject of myth and legend. Fast forward to the present day, and modern scientists are meticulously studying its every detail. With advanced telescopes and sophisticated technology, we have mapped its surface, analyzed its atmosphere, and even sent rovers to explore its terrain. The quest to understand Mars has become a global endeavor, uniting scientists from around the world. Mars has captivated humanity's imagination for centuries, from the early telescopic observations of Galileo to the detailed images sent back by the Curiosity rover. Each discovery has deepened our intrigue and fueled our desire to explore further. The Red Planet, named for its iron oxide-rich surface, is a world of stark beauty and harsh conditions. Its rusty red appearance is due to iron minerals in the soil oxidizing or rusting. This gives Mars its characteristic color and has earned it the nickname the Red Planet. Mars is our closest planetary neighbor and holds the promise of answering one of humanity's biggest questions: are we alone in the universe? The discovery of ancient riverbeds and the presence of water ice suggest that Mars may have once harbored life. If we can find evidence of past or present life on Mars, it would revolutionize our understanding of life in the universe. But Mars is not just a scientific curiosity, it represents a potential second home for humankind. Concepts for human habitats on Mars are already being developed, with plans for sustainable living and self-sufficient colonies. The idea of humans living and working on Mars is becoming increasingly plausible. As we grapple with overpopulation, resource depletion, and climate change on Earth, the idea of colonizing Mars becomes more than just a dream. It becomes a necessity. Our planet's resources are finite, and the challenges we face are growing. Mars offers a potential solution, a new frontier where humanity can start afresh. Mars stands as a beacon of hope, a blank slate upon which we might write a new chapter in human history. The vision of a thriving human settlement on Mars is not just a fantasy, it is a goal that many are actively working towards. With each passing year, we get closer to making this vision a reality. The dream of colonizing Mars is no longer the stuff of science fiction, it is a tangible goal pursued by both government agencies and private companies. The advancements in space technology and the growing interest in space exploration have brought us to the brink of a new era. Government agencies like NASA have been at the forefront of Mars exploration, with missions like the Mars rover and the upcoming Mars Sample Return mission. These missions aim to gather more data and bring back samples from the Martian surface, providing invaluable insights into the planet's history and potential for life. Private companies like SpaceX are also playing a crucial role in the quest to reach Mars. With ambitious plans to send humans to Mars within the next decade, SpaceX is pushing the boundaries of what is possible. Their Starship spacecraft is designed to carry large numbers of people and cargo, making the dream of a Martian colony more achievable. The journey to Mars will be fraught with challenges. From the long-duration space travel to the harsh Martian environment, there are numerous obstacles to overcome. Astronauts will need to be trained to handle the physical and psychological demands of the mission, and new technologies will need to be developed to ensure their safety and survival. But the potential rewards are too great to ignore. The successful colonization of Mars would not only secure the future of humanity, but also open up new possibilities for scientific discovery and technological advancement. It would be a monumental achievement, a testament to human ingenuity and determination. The journey to Mars is a monumental undertaking, requiring unprecedented advancements in space travel technology. Over the past few decades, we have made significant strides in rocketry, spacecraft design, and life support systems, bringing us closer to making this interplanetary dream a reality. One of the most significant advancements is the development of reusable rockets. Companies like SpaceX have pioneered this technology, dramatically reducing the cost of space travel. Reusable rockets allow us to envision a future where traveling to Mars is not a one-time event, but a sustainable endeavor. Another crucial area of progress is in-space propulsion systems. Traditional chemical rockets, while powerful, are inefficient for long-duration missions like a trip to Mars. Scientists are exploring innovative propulsion technologies like ion propulsion and nuclear thermal propulsion, which could significantly reduce travel time and make the journey more feasible. Building a mission to Mars is a monumental engineering challenge. It involves a multitude of complex tasks and requires the collaboration of experts from various fields. From the initial design phase to the final launch, every step is meticulously planned and executed. It requires overcoming numerous hurdles, from designing spacecraft capable of withstanding the harsh conditions of space. The spacecraft must endure extreme temperatures, high levels of radiation, and the vacuum of space. Engineers work tirelessly to ensure that every component is robust and reliable, to developing life support systems that can sustain humans on a months-long journey. These systems must provide a stable supply of oxygen, remove carbon dioxide, and manage waste. They are tested rigorously to ensure they can operate flawlessly for extended periods. One of the primary challenges is developing a spacecraft capable of safely transporting humans to Mars and back. This involves not only the physical construction of the spacecraft, but also the integration of advanced navigation and communication systems. The journey to Mars takes several months, and the spacecraft must be able to navigate through space with precision. Such a vessel must be large enough to accommodate a crew and all necessary supplies for the journey, yet light enough to launch efficiently from Earth. The interior of the spacecraft is designed to provide a comfortable living environment for the astronauts, with areas for sleeping, eating, and working. Every inch of space is utilized efficiently to maximize comfort and functionality. It must also be equipped with advanced radiation shielding to protect the crew from harmful cosmic rays during the long journey. Radiation is one of the biggest threats to astronauts on a mission to Mars, and engineers are developing innovative materials and technologies to provide adequate protection. Another significant hurdle is developing reliable life support systems. These systems must be able to operate independently for the duration of the mission, providing the crew with all the essentials they need to survive. This includes not only air and water but also food and waste management. On Mars, humans will need to be entirely self-sufficient, producing their own oxygen, food, and water. This involves growing plants in controlled environments, recycling water, and generating oxygen from the Martian atmosphere. These systems are being tested on Earth to ensure they can function effectively on Mars. Engineers are developing closed-loop life support systems that recycle waste products and minimize the need for resupply from Earth. These systems are designed to be as efficient as possible, reducing the amount of resources that need to be transported from Earth. This not only makes the mission more sustainable but also reduces the overall cost. Section 4. The Human Element: Surviving the Red Planet. As humanity sets its sights on Mars, the challenges we face are not just technological, but deeply human. Surviving the Red Planet requires us to understand and overcome a myriad of obstacles that test the limits of human endurance and ingenuity. Beyond the technological challenges, a mission to Mars presents significant risks to human health and well-being. The journey to Mars is a long and arduous one, taking several months in the vacuum of space. During this time, astronauts are exposed to a variety of hazards that can have lasting impacts on their bodies and minds. The Martian environment is harsh and unforgiving, with a thin atmosphere, extreme temperatures, and exposure to harmful radiation. Unlike Earth, Mars lacks a protective magnetic field and thick atmosphere, leaving its surface bombarded by cosmic rays and solar radiation. These conditions pose serious risks to human health, including increased cancer risk and potential damage to the nervous system. One of the most significant risks is the effect of prolonged exposure to microgravity on the human body. In the microgravity environment of space, the human body undergoes dramatic changes. Fluids shift towards the head, muscles atrophy, and bones lose density. These changes can lead to a host of health issues, from vision problems to increased susceptibility to fractures. Astronauts living in space for extended periods experience muscle and bone loss, cardiovascular changes, and immune system suppression. To counteract these effects, astronauts must adhere to rigorous exercise routines and undergo regular medical evaluations. Exercise is crucial in maintaining muscle mass and bone density, while medical tests help monitor and address any health issues that arise. Scientists are developing countermeasures, such as exercise regimes, to help astronauts stay healthy during their mission. These regimes include resistance training and cardiovascular workouts designed to mimic the effects of gravity on Earth. Additionally, researchers are exploring the use of pharmaceuticals and dietary supplements to support bone and muscle health, and artificial gravity environments to mitigate these effects. Artificial gravity, created by rotating spacecraft or specific modules, could help reduce the negative impacts of microgravity. By simulating the force of gravity, astronauts can maintain their physical health more effectively during long-duration missions. The psychological challenges of a Mars mission are equally significant. The isolation and confinement of space travel can lead to feelings of loneliness, depression, and anxiety. The vast distance from Earth means that communication with loved ones is delayed, adding to the sense of isolation. The isolation and confinement of a long-duration spaceflight, coupled with the stress of living and working in a hazardous environment, can take a toll on mental health. Astronauts must cope with the constant presence of danger, the monotony of daily routines, and the lack of privacy. These factors can lead to psychological strain and impact overall mission performance. Selecting psychologically resilient crew members and providing them with adequate support will be crucial for mission success. Training programs focus on building mental resilience, teamwork, and stress management skills. Psychological support, including regular communication with mental health professionals and access to recreational activities, is essential to help astronauts maintain their well-being during the mission. Section 5. The Red Planet awaits. Despite the challenges, the allure of Mars remains strong. The Red Planet represents an opportunity to expand our understanding of the universe, search for life beyond Earth, and secure a future for humanity beyond our home planet. The journey to Mars is a journey into the unknown, a testament to human ingenuity and our insatiable thirst for exploration. It is a challenge that will push the boundaries of science and technology and redefine what it means to be human. As we stand on the precipice of this next giant leap for humankind, one thing is certain: the Red Planet awaits.